Who among you is new to networking in general? So I would like to know the pace I will go, and who among you is new with Azure in general?
Actually, I'm not new to Azure, but I'm not a professional. I've not been working with it. Before I know some of the networking aspects, but it's been very long I worked with Azure, so I think I can just hope along.
Anyone else?
I'm not new to Azure, and as for networking, although I just know some basics of networking, being a software developer. Well, so I don't know if I could categorize myself as new to networking, but I think I have a basic knowledge of networking.
Okay, good. So today we'll be talking about implementing network security. So implementing it as well as designing it. So everything as a software developer, as you mentioned, everything you're working on in the front end has a back end, and the back end is just the infrastructure. That's where you find the networking. So a networking powers the back end powers the front end. So that's basically how security and networking are interchangeable. They come in hand to hand. So because an enterprise need to like to run a secured environment, a secured application in a secured way. By security, meaning that you and Microsoft are responsible for that. So according to Microsoft, security is a shared responsibility. So Microsoft gives you a secure tool to run an application and gives you best practices you need to follow. So I think when you follow that best practices, you will not run any risk, security risk or vulnerability or attacks or stuff like that. So so today, that's what we're going to be discussing today. So we'll be looking at network security recommendations with Microsoft Defender for Cloud. Microsoft Defender for Cloud is a generic environment where security is monitored in terms of vulnerability threats, update patches. It gives you an overview, a thorough end-to-end overview of your health posture of your workload running on Azure. So we also we'll deploy an Azure DDoS, so DDoS, distributed denial of service protection, by using the Azure portal. We'll look at an exercise on configuring DDoS protection on a visual network. Deploy and configure network security groups, NSG. Design and implement Azure Bastion. Design and implement Azure Firewall. Look at an exercise on deploying and configuring Azure Firewall using Azure portal. Working with Azure Firewall Manager, and also an exercise on securing your Visual Hub using Azure Firewall Manager, and then implementing a web application firewall. So first and first, there are parameters you will need in ensuring that the application is secured. So look at network security controls, Microsoft Cloud Security Benchmark.
All the module overview, all the items in the module overview, are we going to do them hands-on today, or we are just looking at the theory aspect?
Okay.
All the items in the module overview, are we going to do hands-on practical, or just the theory aspect?
The theory aspect, because of time constraints. So the lab, you get a link where you can click, then you can do the lab step-by-step guide to it. So and I also have some kind of a snippets I put in when I did the lab myself, and I pasted it here. So often, and also often in doing presentation, it might be cumbersome to talk to your core and also do the labs. So from experience, so I take I do the lab myself, then take the screenshot and I bring it and then give you a link. I'll share the PowerPoint. If you click, you're gonna click on a link and then it takes you on a page where you can get a step-by-step guide on how to do the lab yourself. Yeah. So in security, Azure Visual Network, there are steps you need to or consideration look at. Look at the network security controls, Microsoft Cloud Security Benchmark, then how to use Microsoft Defender for regulated compliance, and then managing alerts for coming from Microsoft Azure Defender. So these are the 4 ways or things to consider. The security benchmark is kind of a threshold Microsoft gives on how you're going to run your application based on the industry you're on and based on the environments or the kind of workload you want to run. So network consider controls, we're looking at like establishing network segmentation boundaries, secure cloud services with network controls, and deploying firewall as an edge of an enterprise network. And also looking at NS5, deploying DDoS protection, NX6 deploy web application firewall, and so forth, as you can see. So the network security covers controls to secure and protect Azure networks, including securing visual networks, establishing private connections, preventing and mitigating external attacks, and securing DNS. So for a full description of the controls, you can find it from this link. So the Microsoft Cloud Security Benchmark includes kind of a collection of high impact security recommendations, which you can use to secure your cloud services, whether it's in a single or multi-cloud environment. So they also have the security controls. So what are the security controls? These are kind of the recommendations that are generally applicable across your cloud workloads. And they also have like a service baseline. So the service baselines, like these are like these you are applied. This applies to the controls to individual cloud services to provide recommendation on that service security configurations. And there comes with kind of the control and then the baseline. For a control, an example is like data protection is one of the security controls. And these controls contain specific actions that must be addressed to help ensure data is protected. For baseline, an example could be that a company, say Contoso, looks to enable Azure SQL security features by following the configuration recommendation in Azure SQL security baseline. So how do you use Microsoft Defender for Cloud for regulatory compliance? So if you look at this kind of a snippet of that, so if you look at the Azure portal, you'll go under Defender for the cloud, you will see a snippet of Microsoft Defender for Cloud under the regulatory compliance. The regulatory compliance gives you a benchmark of your cloud workloads across the standard standard that has been measured by Microsoft, the 6 in the industry and stuff like that for your workload. It tells you where your workload is in terms of percentages or the threshold. And that's what you can see from here. So the security benchmark measure like information security policies, organization of information security, human resource securities, asset management, and access control. So you could see in this case that the A6 organization of information security is okay with the green mark, and the red mark shows a point to be addressed. A9 access control. That needs to be addressed to improve that or to improve on that. So basically, you can also see the pointers. So this is the network security compliance issue pointers, and it tells you under it you can see the resource in question that needs to be updated. So it's telling you three of 35 computer machines needs to be addressed, and that's the red. So out of the 35 virtual machines, 3 needs to be addressed. These need to be compliant. So the Microsoft Defender for cloud streamlines the process for meeting the regulatory compliance requirements using the regulatory compliance dashboard. So also another one is like alerts in Microsoft Defender for Cloud. So we have like alerts. So the alerts could be from based on severity of the alerts. So I would widen this up and be visible. So we have the high severity alerts, low and medium. You could see we have a couple of alerts with the red mark with high alerts, severity, DDoS attack detected for a public IP. So the matrix attack, the status that this is active, and affected resources are the cybersec SOC. So when you click on one of these, it takes you to a menu on how steps to take to resolve the error or resolve the attack to address the issue. So we have seen, we have addressed basic security issues on a visual network. Next, we'll look at other topics, so like distributed denial of service, DDoS, Azure DDoS protection standards, type of DDoS attacks, Azure DDoS protection features, deploying a DDoS protection plan, and then we'll take a demonstration. So DDoS is a distributed denial of service. Say you're an organization and say you're working in a platform and you have a web server or an application you're using on to work or an environment, say Azure DevOps environment, where you're doing some scripting and you want to run some application. And it happened that everything went out. You could not access it further. Azure DevOps goes out. That is like a hijack. That's what they call the distributed denial of service. A denial of service is an attack that has the goal of preventing access to services or systems. If the attack originates from one location, it's called DOS, denial of service. If the attack originates from multiple networks and systems, it is called distributed denial of service. Somebody's joining in. So botnets, you see the botnets are a collection of internet connected systems that an individual controls and uses without their own owner's knowledge. DDoS is a collection of attacks aimed at distributing the availability of a target. So this is the target. And then the DDoS involves many systems sending traffic to targets as part of a botnet. So let's say this target is like your a web server or API application, web app. And there are servers in which this application depends on. So when the denial of service happens to the different layers of the backend of this server, then that's what we call it distributed denial of service. And if the attack comes from one location, then it's called denial of service. But if it's like comes from a different networks and systems, that's what we call this distributed denial of service. So the type of DDoS attacks, we have like volumetric attacks. This attack floods the network layer with substantial amounts of seemingly legitimate traffic. The next is the protocol attacks. This attack render a target inaccessible by exploiting a weakness in the layer 3 and layer 4 protocol stack. And the next is resource application layer attacks. These attacks target web application packets to distribute the transmission of data between hosts. They include HTTP protocol violations, like SQL injection. SQL injection, I think most of you know about that. It's quite common. Cross-site scripting and other layer 7 attacks. So, so you can use, how do you mitigate that? You could use layer 7 web application firewall, like Azure application gateway, as well as a DDoS protection standard to provide defense against these attacks. Yeah, as well, other third-party web application you can use, which is being offered in Azure Marketplace. So this is the Azure DDoS protection standard. So DDoS, if you choose the DDoS protection basic, this is the coverage. You get active traffic monitoring and an always on detection, as well as automatic attack mitigation. And the rest is not covered. You don't get an availability guarantee. You don't get a cost protection. You don't get a mitigation policy tuned to customer application. You don't get metrics and alerts, sorry. Mitigation reports, you don't get that. You don't get mitigation flow logs and also the DDoS rapid response supports. But if you choose for the DDoS protection standard, you will get all those protected. So DDoS attacks are some of the largest availability and security concerns facing customers that are moving their application to the cloud. A DDoS attack tries to drain an API or application resource, making it that application is unavailable to legitimate users. So these are the features of a DDoS protection features. You get like a customer, so you have the individual network which you deployed. I have the DDoS protection standard, and then you have is that a public IP? So you have a policy configuration in place, and then you have the public IP 1 and 2. And you have a basic and standard multiple subscription for service tiers. You can also have mitigates the features of the DDoS Azure DDoS feature mitigates volumetric attacks, protocol attacks, and application layer attacks. And also it helps checks for malformed packets and spoofing. So how do we deploy a DDoS protection plan? So first, you could see, we create a DDoS protection plan. enable DDoS protection on a new or existing VNet, configure DDoS telemetry, configure DDoS diagnostic logs and alerts, and then finally we run a test DDoS attack and monitor the results. You can see here. So in the demonstration, we'll create and configure Azure Protection Standard. So you could create that from using this blade shown earlier. So a knowledge check. So we have shown how to deploy a DDoS protection by using the Azure portal. We've also shown how to manage Azure DDoS protection standard using the Azure portal. So next is to deploy and configure network security groups. So network security groups also set default NSG rules, set NSG effective rules. Then we have to create NSG rules. I'm going to use service tags to define network access control, application security groups, and then a demonstration and a review. NSG, network security group, is like a place where you have to do your inbound and outbound configuration of how your network, which ports it needs to talk to, which port it needs to listen to or not to listen to, the IPs, the source, and the location. So as you see, this is the NSG. You configure it on an environment with it limits network traffic to resource in a visual network. NSG lists the security rules that allow or deny inbound or outbound network traffic. And it's associated to a subnet or a network interface. Can be associated multiple times. So you can see the NSG under the NSG blade. So you can see here we have, let's see, okay. So we have priorities, the inbound security rules and outbound security rules. We have the priorities. So under this heading named the RDP inbound, under port 3389, you have access to any protocol, access to any source, and then also access to any destination. So the source IP and the destination IP, and then the action is allowed, fully allowed. And then the last priority under inbound security rules is deny all inbound on any port, both port 3389 and port 80, on any protocol, and any source and any destination should be denied. So likewise with the outbound security rules. So the security rules in NSGs enable you to filter network traffic that can flow in and out of visual network subnet and network interface. There are default security rules. You cannot delete the default rules, but you can add other rules with a higher priority. A network security group contains 0 or as many rules as desired within Azure subscription limits. Each rule specifies the following priorities. The name must be a unique name within network security group, and also the priority. So can be any number of between 100 to 40,906, and rules are processed in priority order. So the rule that has the higher priority takes priority. As you can see, how I showed it here, with the lower numbers processed before higher numbers, because lower numbers have higher priority. So once traffic matches a rule, processing stops. As a result, any rules that exist with lower priorities, higher numbers that have the same attributes as rules with higher priority are not processed. So protocol could be TCP, UDP, ICMP, ESP, AH, or any. So the NSG, Network Security Group Effective Rules. The effective rules, NSG are evaluated independent by for the subnet and the NIC, Network Interface Card. And an allow rule must exist at both levels for traffic to be admitted. Use effective rules link if you are not sure which security rules are being applied. So creating NSG rules. So how do you create NSG rules? So you select from a large variety of services, the destination protocol and the port range for this rule. Port range, single port or multiple ports. Priorities, the lower the number, the higher the priority. So add inbound security rule, custom service, port range 8080, priority 100, port number 8080. Yeah. You can use service tags to define network access controls. So what is a service tag? A service tag represents a group of IP addresses, prefixes from a given Azure service. Microsoft manages the address prefixes encompassed by the service tag and automatically updates the service tag as addresses change, thus minimizing the complexity of frequent update to network security rules. So you can use service tag to define network access controls on network security groups or Azure Firewall. Application security groups, ASG. Application security groups enables you to configure network security as a natural extension of an application structure, allowing you to group virtual machines and define network security policies based on those groups. You can reuse your security policy at scale without manual maintenance or explicit IP address. So we've shown how we assess the NSG blade, and we have shown how to add a new NSG, and they've shown how to explore inbound and outbound rules. Knowledge check. We have shown the Azure Network Security Groups overview, also the Azure Application Security Groups overview. So next topic is design and implement Azure Bastion. So we would connect to virtual machines. In order to connect to virtual machines using Azure Bastions. So this is Azure Bastion. So what is Azure Bastion? It's a way to connect to have access to a virtual machine that is created. You can use RDP, an alternative to use Azure Bastions. So these are links where you can get more about Azure Bastions. So Azure Bastion requires a dedicated subnet. You must create this subnet in the same visual network that you want to deploy Azure Bastion to. So the subnet must have the following configurations. Subnet must be Azure Bastion subnet. Subnet size must be /26 or larger. For host scaling, /26 or larger subnet is recommended. So the subnet must be in the same VNet and resource group as the Bastion host. And then the subnet cannot contain additional resources. So you could see the Bastion subnet for RDP/SSH through the portal or over SSL. Remote desktop protocol for Windows-based virtual machines. Secure shell protocol for Linux-based virtual machine. So we have seen a kind of an introduction to Azure Bastion. And then we've seen a quick start to deploy Bastion with default settings. So next, we would look at design and implement Azure Firewall. So we'll see how to design an Azure Firewall deployment, create and implement an Azure Firewall deployment, and then configure Azure Firewall rules, create and implement Azure Firewall Manager policies, create a secure hub by deploying Azure Firewall inside of an Azure Visual WAN hub, and then integrate an Azure Visual WAN hub with a third-party NVA. So in the kind of overview of the Azure Firewall, we look at the features, rule processing in Azure Firewall, deploying Azure Firewall in Azure Portal, deploy Azure Firewall in hub spoke network topology, and then compare Azure Firewall to NSGs. So the features of Azure Firewall, so you have the standard and the premium SKUs. So you can compare NSG and Firewall. So the features of Azure Firewall are the stateful firewall as a service. I'll make this bigger. Take a look. Built-in high availability with unrestricted cloud scalability. Create, enforce, and log application network security policies. Threat intelligence-based filtering for L3, L7. Fully integrated with Azure Monitor for logging and analytics. Fully integrated with Azure Monitor. Support for hybrid connectivities through deployments behind VPN and express route gateways. And so, like I said again, there's a standard and a premium SKU for you to choose on. So the rule processing in Azure Firewall. So in Azure Firewall, you can configure the NAT rule, network application rules, network rules, and application rules. And this can be done either by using the classic rules or firewall policies. And Azure Firewall denies all traffic by default until rules are manually configured to allow traffic. With firewall policy, rules are organized inside rule collections, which are contained in rule collection groups. A rule collection can be of the following types: destination network address translation, network, or application. So you can define multiple rule collection types within a single rule collection group, and you can define 0 or more rules in a rule collection, but the rules within a rule collection must be of the same type. So that is a DNAT or network or application. So this is an example on how to deploy Azure Firewall and Azure Portal. On the create a fire page, enter the following. You can enter the subscription, so you can see. I'll make this bigger. Enter the subscription. Enter the resource group. Give the Azure Firewall instance name and the region, availability zone, if any. Then you define the firewall tier, define the firewall management, firewall policy. Then choose the visual network to tie it to, and then do a force tunneling. So you can see how to deploy the Azure Firewall. So the key stages of deploying and configuring Azure Firewall are as follows. You create a resource group, you create a virtual network and subnet, create a workload VM in a subnet, then deploy firewall and policy to the virtual network, then create a default outbound route, configure an application rule, configure network rules, configure network rule, configure a destination NAT rule, and then you test the firewall. So deploying Azure Firewall in a hub-and-spoke network topology. So hub-and-spoke network topology, from this link, you can get more information about it. So a hub-and-spoke network it's recommended the shared service are placed in the hub virtual network, and then each environment is deployed to a spoke to maintain isolation. So the Azure Bastion is a kind of a service you deploy that lets you connect to a virtual machine using browser and Azure Portal. The Azure Bastion service is a fully platform managed PaaS service that you provision inside your virtual network. So there's a comparison between Azure firewalls to NSGs. NSG and Azure Firewall, protocol-based traffic, for both of them have that. Both supports service tags. Azure Firewall support application FQDN tags, whereas NSG does not. Both supports integrated with Azure Monitor for diagnostic logging. Lastly, the Azure Firewall NAT and DNAT support is allowed, but not for the NSG. So we've seen what is an Azure Firewall, and we'll look at the features of an Azure Firewall. So next exercise is to deploy and configure Azure Firewall using Azure Portal. So these are the steps you need to take. So you create a resource group, you create a visual network and subnets, you create a virtual machine, then deploy the firewall and the firewall policy, create a default route, and configure an application rule, configure a network rule, configure destination NAT, DNAT rule, and change the primary to secondary DNS address for the server network interface. Then test the firewall, and then clean up services you clean up your resources. So that's what we have learned. And next is working with Azure Firewall Manager. So we look at Azure Firewall Manager features, Azure Firewall Manager policies. Then we look at Azure Firewall Manager for hub virtual network versus secured virtual hubs. We'll look at using Azure Firewall Manager, and then we'll have a demonstration. So this Azure Firewall Manager features: central Azure Firewall deployment and configuration, hierarchical policy, global and local, integrated with third-party security as a service for advanced security, and then centralized route management and region availability. Azure Firewall Manager is a security management service that provides a central security policy and route management for cloud-based security parameters. The Firewall Manager can provide security management for two network architectural types. So the secured virtual hub and also the hub virtual network. And then next is the configuration of Azure Firewall Manager policies. So what is it? So the policies can be created and managed in multiple ways, including the Azure Portal, the REST API, via templates, via Azure PowerShell or Azure CLI. Policies can be associated with one or more visual hubs or VNets. The firewall can be in any subscription associated with your account and in any region. A policy can be created and managed in multiple ways, including the Azure Portal, REST API, templates, Azure PowerShell, and CLI. The Azure Firewall Manager for Hub Visual Network was a secured visual hubs. The underlying resource, Hub Visual Network. So what is it? Basically, Hub Visual Network. This is a standard Azure Visual Network that you create and manage yourself. When security policies are associated with such a hub, it is referred as Hub Visual Network. At this time, only Azure Firewall policy is supported. You can PSPoke visual network that contain your workload servers and services. You can also manage firewall in standalone visual network that aren't peer to any spoke. So what is the Hub Visual Network? So this is like a standalone standard Azure Firewall. This is a standard Azure Visual Network that you create and manage yourself. When security policies are associated with such a hub, it is referred to as a Hub Visual Network. So at this time, you can only use Azure Firewall policy, and that is the only thing that is supported at this moment. So how to deploy Azure Firewall Manager? Use the Hub Visual Network, create a firewall policy, create your hub and spoke architecture, select security providers and associate firewall, then configure user-defined routers to route traffic to your hub network visual and network firewall. Then for the secured visual one hubs, you create your hub and spoke architecture, select security providers, create a firewall policy and associate it with your hub. And next is to configure route settings to route traffic to your secured hub. So there's basically, there's more than one way to deploy Azure Firewall, but the following general process is recommended. So we have seen how to create from this link you can see how to create a firewall policy, create a visual network, configure and deploy firewall, create and connect the VPN gateways, pair the hub and spoke visual network, create the routers, create the visual machine, and test the firewall. So we are seeing what is an Azure Firewall Manager. Next, we'll look at an exercise to secure your visual hub using Azure Firewall Manager. So how do we exercise on how to secure your visual hub using Azure Firewall? So we create two spoke visual network and subnet, create a secured visual hub, connect to hub and spoke with visual network, deploy the servers, create a firewall policy and secure your hub, associate the firewall policy, route traffic to your hub, test the application rule, test the network rule, and then we clean up the resources. So we have seen how to secure your visual hub using Azure Firewall Manager. So next we'll look at implement a web application firewall. In Azure, we have one called Application Gateway. We'll look at web application firewall overview, web application policy modes, the web application firewall for default route rule set, rule groups and rules, web application firewall custom rules, then we create a web application firewall policy on Azure front door. So this is an overview. A web application firewall provides centralized protection of your web application from common exploits and vulnerabilities. Web applications are increasingly targeted by malicious attacks that exploit commonly known vulnerabilities. SQL injection and cross-site scripting are among the most common. Preventing such attacks in application code is challenging. It can require rigorous maintenance, patching, monitoring at multiple layers of application topology. A centralized web application firewall helps make security management much simpler. A WAF also gives application administration better assurance of protection against threats and intrusions. So web application firewall with Azure services, WAF on Azure Application Gateway. So you create multiple policies, and they can be associated with Application Gateway. So WAF on Azure Front Door offers a global and centralized solution. A WAF enabled web application inspects every incoming request delivered by Azure Front Door at the network edge. And the WAF policy can associate to one or more front door front end protection. So you can see these links you can follow to get more about what's an Azure Web Application Firewall and Azure Application Gateway. Also, Azure Web Application Firewall and Azure Front Door. So this is how we create web application firewall policy modes. So and also next is the web application firewall default rule set groups and rules. So like this bigger. Azure managed default rule set includes rules against the following threat categories. So against cross-site scripting, Java attacks, local file inclusion, PHP injection attacks, remote command execution, remote file inclusion, section fixation, SQL injection protection, as well as protocol attacks. So Azure Firewall, Azure WAF with front door allows you to control access to your application, web application based on condition you define. A custom WAF consists of a priority number, rule type, match condition, and an action. There are two types of custom rules: match rules and rate limit rules. A match rule controls access based on set of matching conditions, while a rate limit rule controls access based on matching conditions and the rates of incoming requests. So we show how to create a web application firewall policy on Azure Front Door. This is where you create a web application firewall policy. So this is where you create a basic WAF policy with managed default rule sets. And associate the web policy with a front door profile. So we've seen we've seen what is a Azure Web Application Firewall on Azure Front Door. Also, we've looked at Azure Web Application Firewall on Azure Front Door service. So module review activities on premises and on premises so you can use this diagram to engage and reinforce on the learning, and then look at how you can match these icons, the Azure icons, to where it belongs. So this is basically the presentation of today. I was a bit fast looking at the time, so we'd have everything within an hour. So if I'll share the slides for you to look at it on your own time, and then to see what you can do the lab yourself. Well, how are you doing?
Yeah, I'm fine. Thank you very much, sir. So is there a way I can contact you privately?
Yes, I'm on LinkedIn. I'll see if I can share my LinkedIn accounts. First, stop sharing. Are you not? We also have a LinkedIn group. Sorry, a WhatsApp group.
Okay.
I'll share my LinkedIn.
I'll just if there's a way I can reach out, LinkedIn is fine. I'll be able to send you a private message there.
Yeah, just send it to you. So so feel free to send it to me there.
Okay.
Yeah.
Thank you very much, sir.
Yeah. So I hope you can learn. I will send the slide across on this chart so you could go through it on your own and try some lab for yourself.
Okay, that would be very helpful.
Enjoy your evening.
You too, sir.
Bye-bye.
Bye-bye.
Ciao.